DB mock paper, question 7 on paper 1. So this is all about your financial maths. Eva plans to borrow 60,000 from her bank to start a new business. So this looks like it's a loan. Just remember that you can go to your log tables, and if it sounds like a normal everyday kind of loan, you can use the amortization of a loan formula, which I've found on page 31. So the APR is 5.6% for the full term of the loan. She agrees to pay the loan in equal annual repayments over 6 years, with the first repayment due 1 year after the loan is issued. So that all sounds pretty, standard. Normally I'd have a monthly loan, but that's fine. This is just an annual one. And if I go to log tables, I can get, and it says use amortization. Right, so I'm just going to use the one in the log tables. So the interest and the time have to be the same time frame. The interest has to be in decimal form. All this is told to you in it. And A are it just says here, annual repayment amount. P is your principal amount. So how much do I want to borrow? 60,000. Interest. And 1 plus. It's to the power of T, so it's 4 years, I'm pretty sure. No, 6 years. And all over 1 plus 0.056 to the power of 6 and minus a 1. Throw that all into the calculator and should end up with €12,048 and 83 cents. There's another way of doing it. You could do it without using the amortization of a loan formula, and you could use your sequences and series. You just call your repayments X. The 60,000 is what you borrowed, and you borrowed it right now. So how far into the future is this? It's 1 year into the future. And this is 2 years into the future, and so on, all the way to 6 years into the future. You can fill in your I as the 0.056, take your X out in common, and use your sequences and series to do that, and eventually isolate the X and find out, and you should get the exact same answer. Second part here, complete the table below to show the repayment schedule and the balance of the loan at the end of each of the final 3 years of the loan. All right, so they've given me this. They obviously they want to check, do I understand bit by bit what happens when I'm repaying a loan? So what's your fixed annual repayment? So I'm now looking at using the number that I found up here, which is €12,048 and 83 cents. Now that's going to be the same there because it's fixed. Okay. Interest. Well, this is the amount I have to repay, and I need to get the interest on that. So it's 32,446.54. What is the interest? It's 5.6%. Sorry, so you can see that there. And I end up with 1817.01. And I'm rounding off there because, well, I guess because they should tell me really, but I'm going to round off there, which might affect later. I'm going to round off because you can only pay, to the nearest cent. So that's your interest. the loan repayment then. So I need to I'm going to knock off that much off the interest, and I need to repay that first. And then the rest of the 12,048.83. So I have 10,231 euro and 82 cent. And that will come off the loan. Okay, so that much I pay in interest. I pay that off first, and this is how much I'll pay off the loan. So it's 32,446.54 minus this, which is 22,214.72, and I do that all again. So I have, this is my new amount of money. I need to get the interest rate on that, and I'm multiplying that by 0.056. That gives me 124402 if I round off. 124402. So that comes off this. So that's my 12,048.83 minus that. And I'm down to 10,804 euro and 81 cent when I round off. And so that's the interest that's paid. That's the bit that's paid off the loan. So it's the 22,214.72 cent minus the 10,804 and 81. 409.91. Okay, and we go again. So this amount of money, we need to get the interest on it. 638.95 when I round off. I need to subtract these two. 12048. So that's this amount of it. This money is getting split up between interest and how much the loan that's getting paid off. 0.83 minus the 638.95, and I end up with 11,409.88. There we go. Subtract those, and I end up with actually 3 cents, which is because I've rounded off as I'm going, but there's nothing I can really do about that. 0.03. And that's generally what's happening if you break down a loan. The payment, you dedicate the interest first. You have to pay off your interest first, and then the rest, that bit of the loan will come off. So every time they'll add up to give you that, and you're subtracting eventually to see how much of your new balance you've left. A financial advisor has told Emma that she could save money by repaying the loan monthly. Under this repayment schedule, the APR is charged also at 5.6%. Now, we need to probably change that if we're going to go for monthly. The fixed term of the loan will be repaid in equal monthly instalments at the end of each month. Yeah, that sounds normal. And the term of the loan will remain unchanged. Show the interest rate compounded monthly. Okay, so if I have €1 now, after a year, if that was my annual interest rate, it would turn into 1.056 by 1 plus I don't know, to the power of t. Now, they have to be the same. So because I'm looking for the monthly interest rate, then this has to be in months. Divide by 1. Get the 12th root of both sides. Sorry, I need to get the 12th root. No. I need to clear my calculator. Something's happened. Okay, 12th root of 0.056. And I end up with this. And you can subtract 1 and you'll end up with 0.4. Yeah, 0.4551. Sorry. Percent. They've asked me to use 4 decimal places, so I'm actually going to save that. 0.004551, and I'm going to store that as M in my calculator. So just for myself, I'm going to have stored my monthly interest rate as M. Okay. Find the amount of each monthly repayment correct to the nearest euro. I guess I could just use my amortization of a loan formula again. Might as well, I guess, if that's the fastest way. As I said, you can obviously do it another way, like I did the annual repayments, but I'm going to go again for A equals P I 1 plus I to the power of T all over 1 plus I to the power T minus 1. Okay, so A is equal to P, my principal amount, 60,000, by I, the interest rate, that's now stored in my calculator, 1 plus my interest rate, and that is to the power of, now it's 6 years, but if this is my monthly interest rate, then my time frame has to be in months. So that's 72 all over 1 plus 0.004551, and that's the power of 72 minus 1. Throw that into the calculator, and when you round off, you'll end up with A is equal to 979.18. If you wanted to do it the other way, that's fine as well. And how much would Eva save over the term of the loan by repaying monthly? Give your answer correct to the nearest euro. Well, if she pays annually, this is her annual repayment. 0.83. It's over 6 years, so she's going to pay 72,292.98. But if she does a monthly one, she is going to, where's my monthly? So 979.18. She pays it over 72 months, and that is 70,596. And then if we just subtract those, you'll see that she saves €1,792 over the course of it. Eva's family have offered her an interest-free loan of 60,000 on the condition that she repays the full loan in one lump sum at the end of 4 years. Right, okay. So Eva accepts the offer and decides to invest X money per month in a fund that will earn her a monthly interest rate of 0.2%. She plans to use the fund to repay the loan at the end of the term. Her first payment is due 1 month after she receives the loan. So now they want me to use the sum of a geometric in order to figure this out. So she needs to have the full 60,000 in her account at the end of the 4 years. So off up here in the future, she needs to have her 60,000. So that she can literally just hand it back at the end of the 4 years and go, you know, there it is. Up until that point, she's going to save a certain amount. And each of those will eventually, with a bit of interest on them, etc., give her the 60,000 that she needs at the end of it. Now, we need to have them in the same time frame. So, okay, so there's the interest. Okay, so we need to 1 plus I, we have my interest rate, to the power of t. Right, we're going to bring them all to this time frame here, which is 4 years into the future. Now, she's not going to be able to, she's not going to be able to start saving on the day she gets the 60,000 off her family. So what she's going to do is she plans to use the fund to repay the loan at the end of the term. Her first payment is due 1 month after she receives the loan. So that means that this is 47 months before this, because 48 months before it, they have actually just handed her 60,000, let's say. I know that's not exactly to do with the question here in the way that I'm formatting it, but it is good, I suppose, to have all your time frames here. They have given her this 60,000. She needs to hand them back 60,000 in 4 years' time. So there's 4 years from here to here. And she starts paying this a month after she receives this. So this is to the power of 47, 46, all the way along. And this is, she needs to put in, it's just going to be 1 plus I to the power of 0, or, just x. So I need to take the x out in common. This can be 1 plus I to the power of 45. You get the idea anyway. Take the x out in common. 1 plus I, power 47, 46. Okay. I need to sum this up. There's still 48 months of where she, okay, it's at the end of every month she'll put in money, but there's still 48 terms here. Okay, and in order to do S48, A bracket 1 minus R to the power of n all over 1 minus R. So I'm going to start storing stuff in my calculator now. First term for me is 1 plus .002. That's my interest rate. So they've told me in the question. So 1 plus the interest rate to the power of 47. So there's my first term. I'm going to store it as A. And 1 minus my common ratio. I get my common ratio by getting my second term and dividing by my first term. So my second term is 1 plus 0.002 to the power of 46 divided by, so that's my second term divided by my first term. That's my common ratio. Storing it as B, and then it should be okay. So I have X times, I'm going to fill in this. So A bracket 1 minus my common ratio, the power of this 48 things, all over 1 minus my common ratio. And I end up at X times 50.32676843 is equal to 60,000. And I'm going to bring that over, becomes division. And when I divide, I will get, I have my answer here, sorry, I will get €1,192.21 when I round it off. So I hope that's okay there. And lastly, Eva fails to consider dirt tax in her calculations. Dirt tax is deducted at a rate of 33% from the interest earned in the fund. How much should Eva increase her monthly payments by? Now, increase them by. That's interesting. How much should you increase them by in order to repay the full loan at the end of the term? Right, so she's not repaying 60,000. Sorry. She, it's not the 60,000. It's the tax. So she thought her interest rate was 0.2%. So dirt tax is deducted at the rate of 33% from the interest earned in the fund. So then effectively the interest rate is her 0.2%. And we need to get so she fails to consider dirt tax. The dirt is deducted. The tax is deducted at a rate of 33% from the interest earned in the fund. How much should she increase her monthly payments by? So now we're looking at her interest rate. When I work this out, is now 0.134%. Okay, so I'm back up here and I'm doing the whole thing again, to be honest, except my interest needs to be stored differently. So pretty much writing that all out again. And so the 60x by 1 plus my new interest rate, which is this, the power of 47, my very last one is an x again, is equal to 60,000. So we go again. And this time I need to 0.134%. Sorry, 134%. I can store that now if I want. I don't have to, but I have it stored as M now in case I need it. So again, I'm going to do exactly what I did before. I'm going to take the x out in common. So 1 is left there, it's equal to 60,000. So they're actually making me just repeat this. Just wanted to make sure, could I work this part out? Make sure you ask questions now if you're not sure where I got this out of. So first term, 1 plus, so 1 plus my interest rate, which is the power of 47. I'm going to store that as A. My second term divided by my first term is going to give me my common ratio. So I'm doing all this again. And my second term is 1 plus that is the power of 46 divided by my first term. So my second term divided by my first term. Let's just check that, sorry. I'm not sure I entered that in properly. So my second term, 1 plus my a monthly interest rate bracket to the power of 46 divided by my first term. Okay, is that, and I'm storing that as B, my common ratio, and so X times. So we have my first term, bracket 1 minus my common ratio to the power of 48, close my bracket, all over 1 minus my common ratio. That gives me 49.54305045 is equal to 60,000. Get your 60,000 and divide it by that, and you end up with X is equal to 1211.07. Now, this is when she forgot to include her dirt. This is when she includes her dirt. So what's the increase? It's €18.86. So increase of €18.86.